In this video, we're going to look at how to take decimals into fractions. Now, these are easy. I'm not going to go into the detail of these. I'm going to do them. More importantly, going to look at how to get recurring decimals and writing them as fractions. So the first two are pretty easy. So if you had 0.2, you would say, okay, well, that's 2 over 10. And I can just simplify that to a fifth. And 0.3, that would just be 3 over 10. And then you'd get 0.3 recurring, and you'd be like, okay, how does it work? So you can pause the video and think what that is. I know initially, if you go this route and you look at this, you might say, well, I don't really know what the answer is. Is it going to be 3 recurring over 10? We don't know what's going on. But if you pause the video and think about it for 60 seconds, I'm sure you're going to get to the answer. And it's a fraction that you actually use a lot. You've seen this fraction a lot. And the answer is actually just, wait for it. Let me get the other pane. Hopefully you paused and think. Pause and think now. Okay, it's a third. Now the question is, how on earth did we get there? It makes sense to us logically, I guess. We know a third, 1 divided by 3 is going to give me 0.3 recurring on my calculator. But the question is, if we get weirder ones like 0.4, for example, how are we going to write this? Because that's obviously not a quarter, right? It's not as easy as that. So it's kind of a process, and we use some algebra to get there. So let's quickly take a look at what we do. So we find kind of steps, and the first step would be, if they asked us about the 0.3, we'll say let x be equal to 0.3 recurring. So x is equal to 0.3 recurring, and then I'm going to multiply both sides with 10. So if x is 0.3 recurring, then if I multiply x by 10, I get 10x, and you might be like, why on earth am I doing this? It'll become clear in a moment. 0.3 recurring times 10 is going to be 3.3 recurring. Now, if I were to write this 3.3 recurring, 3.3333, blah, 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 blah. And if I were to subtract the top number, which is 0.3333, blah, 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 you would see that these recurring bits, they are exactly the same. So if I were to take 3.3 recurring minus 0.3 recurring, these would actually just cancel out, and I'm left with 3 minus 0, which would just be 3. So that's what's happening on this side. If I were to, let's say, minus it, I can maybe write it a little bit better by saying, okay, 10x minus x. This part you can write as you want, I guess. And that would be the same as 3.3 recurring minus 0.3 recurring. This is one method of doing it. And then 10x minus x would be 9x. And we saw this is going to be 3. So I'm left with 9x is equal to 3. And then I just divide by 9 on both sides because I just want x alone, right? So then the 9's reduced to 1. So we're left with x is 3 over 9. And 3 over 9 can be simplified to 1 over 3. And then we see that's where the third comes from. This step, you don't necessarily have to write it in that way. You can maybe say something like, this is my equation 1, and this is my equation 2. And then write a little bit saying, okay, well, I'm going to take equation 2 minus equation 1 for whoever's marking my test. And then 10x minus x is going to give me 9x, and then that minus that is going to give me 3, and carry on from there. So this is not necessarily the step you have to show. You don't have to show that either. The important bit is what they want to see is this: let x be something and let 10x be something else. So let's take a look at another example. Let's take just the next number we had on the board, which is 0.4 recurring, and you're going to see it works exactly the same way. So we're going to start with let x be equal to 0.4 recurring. I'm going to multiply it by 10 on both sides, and then 10x is 4.4 recurring. And if I do, let's say 10x minus x, that's going to be 9x, and 4.4 recurring minus 0.4 is just going to give me 4. And then dividing by 9 on both sides is just going to give me 4 over 9. Okay, you might see a pattern that if I had 0.1 recurring, that would be 1 over 9. 0.2 recurring would be 2 over 9. The 0.3 recurring was 3 over 9, but we simplified it to a third. And 0.4 recurring is 4 over 9. So yeah, for the single digits, it's pretty straightforward. Even if you were to, I wouldn't just write it directly as that. I would at least show this step because that's usually in the memos. But if it's just 1 mark, I guess it's fine to go that way. But if it's 2 marks, I definitely want to show a mark. In the next video, I'm going to do something a little bit different where we have 2 numbers recurring.